guys, welcome to another episode of MrLopezClasses.com. We are going to continue in our book of auxiliary systems, and this is the episode number 1 of the chapter 6. And yes, today we are going to talk about the gyros and the stabilizers, and how those electrohydraulic systems are integrated in the boat with the rest of the systems. Yes, those systems are hydraulics and electrohydraulics, the majority of them. Until today, we know a couple of stabilizers. You remember the flaps on the twin taps? Those are stabilizers. Yeah, the twin taps stabilize the boat along the axis, along the key of the boat. The flaps stabilize the boat. But there are other stabilizers, lateral stabilizers. Those are fins. Those are fins, like this, like the second ones. Those are lateral stabilizer or fins. Those systems are hydraulic systems normally integrated in the central hydraulic unit of the boat. You remember the central hydraulic unit with the electric motor AC or DC? Yes. One of the groups of solenoid valves is dedicated for the fins, for the stabilizers. Those fins, the second ones over there, are very common in big boats, in mega yachts, boats bigger than 95 feet. The majority of those boats, they have fins, and that system is integrated with the central hydraulic unit. The inconvenience with those fins is when you need to lift the boat out of the water with the travel lift. If the operator of the travel lift is not an expert, it's possible damage those fins with the traps, with the nylon traps. And yes, or during the docking procedures, those fins normally are affected. I remember I visited a boat some years ago, and I found that one of those fins was bended, and the boat was under reparation. I remember the boat of our friend Danny Ramirez. Those are the fins. In this particular case, this is the port side fin, is in good condition, but however, the starboard side was broken. Right now we are going to check the starboard side is in reparation because the captain hit the fin against the ground, the rocks. In this particular case, the winglet was broken and is on reparation in this moment. Was removed. The winglet occupied that space. Right now is removed, is in reparation, and you can see in the bottom the shaft of the ram. Yes, in that case, the fin was damaged, and now the fin is under reparation. Normally, those fins, the second ones, are hollows. They are fabricated in fiberglass, and they are hollows. On top, those fins, they have servo cylinders, and those servo cylinders are integrated with the central hydraulic unit. Those servo cylinders compensate the lateral movement of the boat, especially with the boat in movement. Those systems in small boats are not used. In small boats, they use this system, the gyro, the second one. The gyro, like the name said, is a gyroscope. The concept is similar to the gyroscope, but internally, those systems, they use a couple of flywheels like this, and those flywheels work like equilibrators of momentum. If the boat is rolling in one direction, the flywheel operate in the opposite direction at high RPMs, and compensate the momentum in order to equilibrate the momentum of the boat. You remember the definition of momentum we explained in previous episodes. Is basically the torque, the force times the distance, and that momentum in one direction should be equilibrated with other momentum produced for the flywheel spinning in the other direction. In other words, those gyros works in this way. This is the axis of the gyro, and this is the ball. Normally the gyro is mounted over stringers in the boat. Normally those gyros are installed in the center of the boat. It is possible, it's better in the center of the boat, stem of the boat, close to the transom. In some cases, it's not necessary install the gyro offset, not necessarily in the center. Like in the interview that we have right now with Jonathan Kapak, we are going to try to understand that situation. He's an expert in the installation of those type of gyros. Yeah, those elements are over the stringers. Those are the stringers of the boat, and additionally, that element have a bracket, and the bracket have actuators. The cylinders, the actuators, compensate the axial movement of the boat, like the trims, and the flywheel located inside. The flywheels and the actuators are hydraulics, and those hydraulic actuators work all the time compensating axial movement and lateral movement. That fluid in a couple of minutes is too hot. For that reason, those elements are connected with a small reservoir, and the small reservoir is connected with a strainer and a raw water pump, and the raw water pump suction salt water. Normally, the fluid of that system is hydraulic systems. In other cases, they use glycol. You remember, glycol is a combination of water and aromatic refrigerant, 50-50. Exactly. There are systems that use glycols, and other systems use hydraulic fluid, and that fluid is cooled by raw water, and the raw water circulate with a pump, raw water pump, a strainer, and enter in the heat exchanger. In the heat exchanger, in this particular case, we have coolant in the middle, and raw water cool the coolant, similar to the heat exchanger used for gas and diesel engine. You remember? Exactly the same. And those heat exchangers have a pencil sinks. Those heat exchangers have a pencil sinks, and this is part of the service each 200 hours. For those type of gyros, they need to replace the pencil sinks, and they need, in some cases, flush the coolant, the glycol with water, and or hydraulic fluid, if it's depending of the manufacturer, and keep that hydraulic system working properly. Remember, my friend, that a hydraulic system is a system with any type of fluid. Doesn't matter if it's water, hydraulic oil, if it's coolant. Those are hydraulic systems, right? Because it's hydraulic fluid. Okay, this is the gyro, and we are going to check the installation of a gyro in a boat in Jupiter, in Florida, with one of my former students that is working in a great company dedicated to gyros. Is a.c.r. He is working in a company that is dealer of a.c.r. Gillen Diesel. Gillen Diesel is a dealer of a.c.r. and Jonathan Kapok is working over there installing a gyro. It's a nice process because the boat is in this moment in the rack in a marina. The inconvenience of the video is that the video is a little dark. I apologize for the inconvenience, but I hope you enjoyed the interview with Jonathan. Once again, the light inside of the building was no good, and we have technical problems during the record of the video, but I hope you enjoyed the video. During the installation, they have the truck, nice truck, and it's a wonderful truck with the crane in order to install the gyros. Let me show the truck. This is the truck. Danny, we have a great truck. We have generator, the central hydraulic unit with the reservoir for the hydraulic fluid,
and then your fuel tank for the
fuel tank for the generator.
It has a hoist.
Oh, and look at the actuator for
to stabilize the truck.
To stabilize the truck.
You get your power.
No, look at
and your hoist.
The hoist, yeah, wonderful. And look at the cabinets for the tools.
With lights and everything.
Yeah, with lights. This is a nice truck. This is a perfect example of a electro-hydraulic unit. Look at the servo valves.
Yep.
Look at the servo valves. Look at the actuator. Big actuator, and the other actuator. And the telescopic system.
Yeah, the boom.
The boom. Wonderful.
And now with the truck, they try to introduce the gyro in the hall that they prepare. They prepare the stringers, they install brackets, and now they introduce the gyro carefully. After that heavy job, they now start to connect the gyro. Right now they need to connect the electrical part of the gyro because the gyros are in a DC or AC. The gyros DC are basically for small boats, less than 35 feet, and the gyros AC gyros they are for boats bigger than 40 feet. In this particular case, it's an Intrepid boat with 3 outboards. It's 41 feet the length of the boat, and the gyro is a gyro K5, I think so. It's a gyro that is working with 120 volts. For that reason, in that particular boat, the customer replaced the generator, the original gasoline generator, for a diesel generator 7.5 kilowatts in order to keep the gyro with good power, with good AC power, because that boat is used for fishing, and they need the gyro working properly. In that case, the gyro is AC, but there are gyros DC. Okay, one of the connection is the electrical connection, the supply power for the gyro, and the other one is the data. The data have 2 chances. You can connect the gyro alone, stand alone, with your own display and with your own network, or you can integrate the gyro into the NEMA 2000 with the rest of the boat. In this particular case, the gyro will be integrated only with your own platform, with your own network, with your own screen, and that screen will be installed in the console properly. This is the interview with Jonathan Kapak. Today we are with Jonathan Kapak, an expert in hydraulics, in gyros, in stabilizers. Great job, no?
Yeah, thank you.
How long is this boat?
So right now we're currently on a 40 Intrepid, 2018 40 Intrepid.
Okay, and the idea is install a gyro.
Yes, so this customer gave us a call, and he had a gas generator, a 5 kW Western Peak, that was giving him a lot of problems. So he wanted to go with a DC unit because he couldn't figure out how to get the generator working constantly. So we posed the idea like, hey, let's rip that one out. Let's put a 7.5 kW Onan generator, a diesel generator, and then we could put a bigger Seakeeper inside the boat.
Okay, in this moment, that Seakeeper is AC.
Yes.
And is with power coming from a new generator coming 7 kilowatts.
7.5.
7.5. All right, that's good.
Yep.
And is heavy?
The Seakeeper itself,
Yeah.
yes, it's just shy of 800 pounds.
800 pounds. It's a lot, no?
Yep.
All right. Now we check the procedure to accommodate the gyro on the place. I suppose that previously you repair the stringers, the fiberglass, to support the gyro, no?
Yes. So originally this was this compartment had the generator forward, so we pulled out the old, put in a new, and then there was a storage compartment for dive tanks.
Oh, okay.
So we built onto the transverse stringer that was there,
Uh-huh.
and then we put 2 longitudinal stringers, and we used that aft bulkhead, and we beefed that up. So we boxed everything in.
This is a job for 3 days?
Oh no, 3 weeks.
3 weeks.
3 weeks.
How many people working on it?
So we had 2 fiberglass guys going. We had 2 technicians doing all the wiring and doing all the plumbing as well.
Okay. The selection of the gyro is according with the length of the boat, or
Yes.
there are other factors?
So the length of the boat and then also the weight of the boat.
The weight of the boat.
Also, it depends what you're using the boat for.
This is important, no? Because I suppose that it's different if the boat is a fishing boat with a big tower.
Oh, absolutely.
Completely different, no?
Yep. So this particular customer, he was back and forth between a Seakeeper 3, which is all DC powered, and a Seakeeper 5, which is AC powered.
AC power. Oh,
But
okay.
he was scared of the 5 because the generator was so unreliable. But we fixed that. So I asked the customer, well, what's your intentions? What do you plan on doing with the boat? And he said he wants to go to Bimini, across the Gulf Stream. So I said, hey, we need to go with the 5.
Oh, yeah.
So it'd be a lot different if you're toting around the intercoastal and bar hopping in Jupiter, but you could get away with a 3. But if you're going to Bimini or anywhere in the Bahamas doing some hardcore fishing, you should go with the 5.
In general term, how much is the price of this conversion?
So this install cost roughly about $65,000.
65,000 included the gyro
Yes.
and the new generator?
The generator
It's separate.
separate, yes.
Oh, it's another
20,
cost.
20 stacks.
Oh,
yeah.
okay, all right. Okay, and in 3 weeks, 3 people working hard. It's a big job, no? It's a
Yes,
big project.
absolutely.
Okay, now in this moment, the gyro is on place. What is the next step?
So to get the gyro in place, we really wanted to avoid cutting this hatch. So what we did is we unlocked the brakes to the technician page, and we precessed the gyro all the way aft, and we locked it. So that way when we picked it up, it was at an angle.
Oh, okay.
And then we removed the trunnion arms on both sides.
Those arms.
Right here. So because you can see the angle wasn't allowing us to get in. So once we removed those, we were able to maneuver the gyro in place, and now we're gonna put these back on and bolt everything back
What
down.
is the function of those brackets?
So this is referred to as a trunnion arm. There is 2 hydraulic brake arms that go right in here, and that holds everything in place.
This is the pivot of the arms.
Yes.
Okay.
And then you have 2 19mm bolts on the front side and back side that bolt into the frame.
And what is the function of the actuators?
So the Seakeeper has what's called an IMU, inertia measurement unit, and it's all pre-calculated sea states.
Oh, okay.
So we beat the hell out of all our units up in the North Atlantic, and we come up with these pre-calculated sea states, and everything's programmed into the IMU. So now when the boat goes to roll, the IMU can sense what kind of sea state it's in. So when it goes to roll, it sends a signal back to the computer, and that computer sends a signal to the actuators and the rams to open or close. So when the gyro goes to precess forward and aft, it's constantly fighting to stay upright, and that's what creates your angular momentum and balances out the boat.
That's wonderful. In other words, this is an electro-hydraulic unit.
Yes.
Oh, correct. And the hydraulic system is coming from a central hydraulic unit, or what is the hydraulic unit?
So we have a hydraulic manifold on there. So it's all internal. The Seakeeper has no external components.
Everything is
Yep.
internal. Okay.
What you see is what you get.
All right.
So on the hydraulic manifold, we have one accumulator to maintain the constant pressure inside the manifold,
Correct.
which is 350 psi, and that manifold relays back to the computer. So when the IMU sends the signal to the computer, then the computer tells the solenoids on the rams to open or close.
Correct. This is a perfect robot. No?
Almost.
Yeah.
Yeah.
Yeah. Of course.
Almost.
And the hydraulic, at the end of the day, is too hot. That system use a special heat exchanger.
Yes. So we cool the system by so on this boat we popped in a through hole which goes to a strainer, and then from the strainer it goes to a 115 volt pump. We use a self-priming pump, so if this guy is up on plane, we don't have to worry about the pump getting airlocked and causing overheating issues. So then that seawater goes into the heat exchanger and cools the glycol that circulates throughout the system.
Oh yeah, it's glycol, it's
Yes.
coolant.
Yes,
It's
50-50 radiator.
50-50
Yep.
radiator coolant. All right, that's nice. And in the service periodically is change the level of the coolant.
Every 3 months, it's really on the owner and captain to check the status of the zinc. Just a small pencil zinc.
Yeah, pencil zinc. Yeah.
So go ahead, swap that out. I put a little Tef gel on the threads to help you out next time. And then once a year, give one of us a call, and we'll come out, we'll swap out the accumulator on the manifold, flush new hydraulic fluid through there, repressurize the system, we'll do change the zincs, recalibrate that angle sensor, and then flush all the coolant in the system. We take it a step further and we descale the heat exchanger too with some barnacle buster.
This system use a separate monitor, separate control on the console, or is integrated into the NEMA, into the main console?
So we do use NEMA backbones, but this is completely isolated. So what we have going on here is in order to get the sphere in place, we manipulated the gyro in one position, we locked it, and then when we had it in a certain position in the hole, we had to unlock the brakes. So we just use an inverter or a converter.
Yeah.
And we used 24 volt or 12 volts, excuse me, to the back of the Seakeeper, and we hooked up a separate display. So now we can control
separate
it.
display.
Yes.
Okay.
Yep. So the display on this boat is actually right under the helm.
On the helm. Okay.
Yep.
All right.
So it's completely isolated. It does use a NEMA T and a terminator, but it's not connected to anything else.
Oh, it's completely isolated. We have another question, Glenn.
Yeah, it seems like a round ball. What's in there? What the weight? How does it move?
So what's going on is inside that sphere we have a flywheel that spins up to 9,000 RPMs. So the sphere itself is completely sucked down of atmospheric pressure. So atmospheric pressure is measured in torr. So the torr level is about 6 to 9 in there. So what that allows us to do is spin the flywheel faster with little to no resistance. So that's why we're able to put a Seakeeper on such a small boat, because the amp draw is so little. So now we're taking 115 volts, it's going into the motor drive box, and then it gets converted into 400 volts into a fixed stator motor in the bottom of the unit. That's what spins the flywheel. So then now when the boat goes to roll and the brake arms are doing its thing, fighting to keep the sphere upright, that angular momentum is then distributed throughout the gimbal caps into the stringer system and bounces out the boat.
Nice, huh?
Oh, that's good.
That's good. In other words, that sphere produces an opposite momentum. If the boat is inclined in this direction, the sphere is moving in the other direction with opposite momentum, and equilibrate the equation.
Yes. Yeah. So you have an X and Y axis pretty much, right? So as that flywheel is spinning and the boat goes to roll, the sphere precesses forward and aft, and then the brake arms are fighting to keep that sphere upright, and that's what the angular momentum is how the angular momentum is created, and that goes into the gimbal caps, and then that is distributed throughout the
that's
stringer
wonderful.
system.
This is basically an equilibration of momentum equation.
Yeah.
That's,
I have a question for you.
Sure.
So now they have, for like the smaller boats, they can have on just a DC circuit for the same Seakeeper, right?
Yes. So recently we just we've done a lot of boats recently, but we did a 28 regulator. So that boat got a Seakeeper 2, which is all DC powered. So we made a custom bracket, and we mounted that right to the bottom of the bilge. And then we just added to the house batteries.
Oh,
And one more question. So you guys are the only ones that produce a gyro like this for small boats in DC power only, correct?
Yes.
Okay. That was a,
good
I remember
question.
him. Yeah, I remember him telling me the last time we spoke. It was,
yeah. And I have
DC.
another question. Is if the gyro is for a small boat DC, you need a big bank of batteries?
So typically we either can add to the house batteries, or we can create our own bank.
Yeah.
So if we create our own bank, we try to advise the customer 2 to 3 batteries. If we're adding to the house, depending on the unit, we can add 1 to 2.
Suppose I have a 4 batteries series 27 connected in parallel. Suppose that the gyro is 12 volts. I have around 300 amps per hour. That amount of amps is good for how many hours?
300 amps will last you almost all day.
All the day. Oh, okay.
That's good.
Oh, it's not.
That's not bad at
excessive.
all.
It's good. It's nice because if you have a couple of solar panels,
you can maintain.
you stay the day. Oh, it's nice.
Yeah.
Yeah, there's a lot of ways you can switch it up and power the boat. It's really what all the customer wants. Most customers just want the simplest way.
Yeah,
They want to get their boat.
This is nice for
back in
a
their
small
hands.
boat in Bahamas, dancing all the day.
Yep.
Yeah,
There you
That's
go.
good.
absolutely.
I like it. This is a good design. You have another question, Glenn?
No, it just, that's the first time I seen it, so
Yeah.
from what I'm hearing, it's great. I mean, it'd be nice to go out, like you're saying, you got a mate or with bait, you're trying to, in these rough seas, fishing,
Sure.
it calms it down for you.
Correct.
And
Correct.
that's
Correct.
pretty good.
Gotta put one in your boat now.
Yeah.
A lot of guys that fish tournaments have Seakeepers because you're going to gaff a fish and you miss, now the fish gets away, you just lost the tournament.
Yeah.
Versus the guy with the Seakeeper, isn't having that issue.
Yeah, that's true.
Oh, that's cool.
That's true. That's true. Oh, nice. I love the design.
It's awesome.
Wonderful.
Technology is awesome.
This
And,
is-
and how long have they been around? How long is it?
Like 2010-ish. So they're built right outside Philadelphia. It used to be a NASA machining shop, and then during the last administration, that I guess all the space stuff kind of took a dive. So Seakeeper swooped in and said, "Hey, we need a couple prototypes," and everything started from there.
Cool.
Nice. Where is the headquarters of a Seakeeper?
So the headquarters is in California, Maryland.
Okay.
And then the actual factory is right outside Philadelphia, Pennsylvania.
Oh, Pennsylvania. And in that building is where the engineers are thinking, calculating those equipment depending of the boats, no?
Yes. Yep. So everything's kind of been figured out. There has been a lot of research and development done in the last few years, and Seakeeper's done a great job of really narrowing that down. So once the unit's built, then it's tested at the factory. They have a tilt wheel. They put the unit on there and they beat the hell out of it for 6 hours before they send it out to us.
In order to summary the information, suppose that I am the owner of a boat. I call for a gyro in my boat, and you ask to me the length of the boat, the weight of the boat, the use of the boat, the power that I have in the boat, AC or DC, and
Yes.
what other information you need to calculate the gyro appropriated for my boat.
That's really it. It really comes down to what you're using the boat for.
Yeah.
Because there are some gray areas, like on this particular boat, we could have put a Seakeeper 3 in here, which is all DC powered, but because the guy likes to fish, I said, let's go with a 5, because
Okay.
you get the most out of it.
And I suppose that other important question is where is the area that you want to install, or we need check the boat in order to verify if the center of the boat is free?
So it doesn't have to necessarily go in the center of the boat. It could be offset.
Oh, really?
Yep. So that doesn't matter. So with the IMU, when you go to feel that sea state, that roll, the timing may be just off by a fraction.
Oh, this
of a
is
second.
new. You
Something
can
that you-
install a little
I
Something you
can't
probably
believe
wouldn't
you could
recognize.
offset it and
Yeah.
it still levels the boat.
Not only that, you can have it above deck because I've seen it at the boat shows. They've had one that's above deck, like a console where the seat is, and you have the gyro underneath there as well.
So if we're gonna go do that, we have to ensure that the deck is
The deck can withstand it.
secure.
Yeah.
I have two questions.
Sure.
Is there any noise to it? Any?
Very, very little.
So you won't hear it.
No.
Cover on,
No.
fishing,
Doesn't scare away the fish either. So
and it's a diesel generator.
yes,
So and you got gas motors.
yes.
Excuse me. So you have to put a separate gas
separate
tank.
tank, no?
Yep.
Okay.
Oh, that's the idea.
Yeah.
Yeah, this is a good question because this boat is outboard gasoline, and now we need to introduce another fuel tank exclusive for the generator. But I prefer the diesel generators.
Oh, yeah.
They are more reliable. It's better.
And last longer.
No,
Absolutely.
exactly. Oh, wonderful. Another question, Dr. Rodriguez.
I think that's good, man. You guys
Yeah.
asked all the questions I could ask.
It's surprise, no?
That's good.
Thank you very much.